Here we will see non-clustered index in SQL Server. The SQL non-clustered index is similar to the clustered index. When it is defined on a column, it creates a special table which contains the copy of the index columns along with a pointer that refers to the location of the actual data. However, unlike clustered index, a non-clustered index cannot physically sort the indexed columns. Non-clustered indexes have a structure separate from the data row. It contains the non-clustered index key values, and each key value entry has a pointer to the data row that contains the key value. The pointer from an index row to a data row is called a row locator. The structure of the row locator depends on whether the data pages are stored in a heap or a clustered table. For a heap, row locator is a pointer to the row, and for clustered table, the row locator is a clustered index key. You can add non-key columns to the leaf level of the non-clustered index to bypass existing index key limits and execute fully covered indexed queries. A non-clustered index or a regular B-tree index is an index where the order of the rows does not match the physical order of the actual data. It is ordered by the columns that make up the index. In a non-clustered index, the leaf pages of the index do not contain the actual data, but instead it contains pointer to the actual data. These pointers would point to the clustered index data page where the actual data exists. In this example, we have a sample database table with two columns as ID and name. If we create a non-clustered index on a column named ID in the above table, it will store a copy of the ID column with the pointer that points to a specific location of the actual data in the table. The main goal of creating non-clustered index is to improve query performance by speeding up the data retrieval process. SQL Server allows to create multiple non-clustered indexes, up to 999 non-clustered index on each table that can cover our queries. Any index added to the table will negatively impact data modification performance on that table. This is due to the fact that when you modify a key column in the underlying table, the non-clustered indexes should be adjusted appropriately as well. When designing a non-clustered index, you should consider the type of the workload performed on your database or a table by compromising between the benefits taken from the creating new index and the data modification overhead that will be caused by the index creation. It is recommended to create a minimum indexes with a minimum number of columns participating in the index key. A table that has large number of rows with a low data modification requirement can heavily benefit from more non-clustered indexes with composite index keys that contain more than one column in the index key, and that will cover all the columns in the query to improve the data retrieval performance. This diagram shows the pictorial representation of B-tree structure of the non-clustered index in the SQL Server. Both clustered and non-clustered indexes has the same B-tree structure, that is having the root node, intermediate node and leaf node. The only difference between the clustered and non-clustered index is how the leaf nodes are worked. In case of clustered index, the leaf node holds the actual data. On the other hand, in non-clustered index, leaf node has a row identifier, and this row ID points to the different things based on the situation. If your table does not have clustered index, then the row identifier of the non-clustered index points to the heap table. A heap table is nothing but the table without indexes. In the heap table, it will search the record row by row until it finds the data. If your table has a clustered index, then the row identifier of the non-clustered index will point to the clustered index key, and that index key is used for searching the data. Then we'll see advantages of non-clustered index. First is flexibility for multiple indexes. You can create multiple non-clustered indexes on a table and each optimized for different queries. Next is efficient for specific queries, which is ideal for queries that involve searching for specific values in the indexed column. Next is minimal impact on data insertion. Unlike clustered indexes, non-clustered indexes have less impact on the performance of the data insertion, as they don't dictate the physical order of the entire table. And next is covering indexes. This can be used to create covering indexes where the index contains all the fields required by the query, leading the faster query performance. And then we'll see disadvantages of non-clustered index. First is additional disk space. Non-clustered indexes are stored separately from the table data, which requires additional disk space. This can be a significant factor in the database with a large number of indexes or large data sets. Next is write performance overhead. While non-clustered indexes improve read performance, they add overhead to the write operations. Each insert, update or delete in the table may require corresponding changes in the non-clustered indexes. Over-indexing. Creating too many non-clustered indexes can lead to the performance degradation. Each additional index increases the complexity and time required for the write operations.